planets in our solar system, the only one capable of sustaining life is Earth. The only reason this is possible is because of a thin layer on the surface called the atmosphere. This layer has two primary purposes. The first, to sustain life, and the second, to protect Earth from ultraviolet or UV radiation. UV radiation are invisible short waves of radiation from the sun. The Earth's atmosphere contains a mixture of the following particles and gases: water vapor, carbon dioxide, methane, nitrous oxide, and ozone. These all make up a small percentage of the atmosphere. Human activities have a large effect on the atmosphere. A primary example is coal mining, which causes air pollution. And air pollution affects everyone's health, especially young children, the elderly, and those with respiratory and heart conditions. According to Environment Canada, there are 6,000 premature deaths each year in Canada's 8 major cities due to air pollution. Poisons in the atmosphere. Persistent organic pollutants, or POPs, are highly toxic substances often found in pesticides and other industrial chemicals. These POPs are the most dangerous human-made pollutants ever released into the atmosphere. The grasshopper effect is a global phenomenon where POPs move from warmer to cooler regions. They first evaporate, travel through air currents, then condense over a new region. They tend to concentrate in cold regions since condensation is higher there. The impacts of POPs include cancer, reproductive problems, birth defects, damage to the immune system, and death. Bioaccumulation is the buildup of chemicals such as POPs within organisms. These become increasingly concentrated as they move up higher in the food chain. In Canada, the highest rates of POPs are found in the Arctic. Therefore, polar bears have some of the highest levels of POPs ever detected in wildlife. So, what can we do about this? Canada and 8 of the world's northern countries have developed the Arctic Monitoring and Assessment Program to establish a database of Arctic contaminants and to provide scientific advice to make preventative actions. Acidic deposition. Acidic deposition comes in multiple forms that include acidic materials in liquid, gas, and solid forms. I will be discussing only the liquid form, which is acid rain. This is where the grasshopper effect comes into play. Next, there are 2 primary types of smog that I will focus on. The first, Los Angeles smog, and the second, London smog. Los Angeles smog is caused by sunshine, high humidity, and pollutants. This was first identified in the late 1940s. LA smog can also produce photochemical smog. This is smog produced by a photochemical reaction among sunlight, hydrocarbons, and nitrogen oxide. On ground level, this smog damages trees, reduces crop yields, and corrodes materials including metal and rubber. The impacts of LA smog include the irritation of eyes, nose, and throat, permanent lung damage, and increased risk of lung cancer. What can we do about this? We can reduce sources of pollutants, burn clear gasoline, limit the number of cars on a road during a major smog overbreak, and use non-gasoline burning vehicles. London smog is caused by burning fuel that releases sulfur dioxide. This smog stops the air from rising, resulting in a lack of air circulation. Therefore, having the same air trapped at the ground level for extended periods of time. 120,000 people die each year because of this smog. So, what's being done about this? The British government has passed the Clean Air Act. This act has set up smokeless zones and gave incentives to homeowners who use electric heaters, therefore producing less pollutants. Ozone depletion. Ozone is a substance that both hurts and protects us. When formed at ground level from a photochemical reaction, it is harmful. But when formed in the stratosphere, it absorbs UV radiation and protects us. For every 1% decrease in the ozone in the stratosphere, the amount of UV radiation that reaches Earth doubles. This causes a significantly higher risk of skin cancer. So, what's been done about this? The Montreal Protocol was passed in 1987. This is an international agreement that decreases the number of ozone-depleting substances released into the atmosphere each year. We can only hope to resolve the problems of acidic deposition, smog, and ozone depletion. There is currently not enough being done. We need to change our ways, and we need to do it fast. Our planet depends on it.